So in this video, I want to introduce some terminology that is going to help us talk about different ways that we can hook electrical components up to each other. So let's start with a really simple situation. Let's say we just have a wire with a current. All right, so the way that we draw a wire is just a solid line like this. And if you want to indicate that there's a current in it, well, it turns out the current is going to be the same at different places along the wire. And that just has to do with the fact that you have a flow of particles, in this case electrons, and the electrons don't get used up. They don't, split off in different directions. We just have this, constant current throughout the wire. All right. Well, that's not a very interesting situation. And so in real life, we're interested in cases where there are things going on. So let's say that we put some obstacles in the path of the current. Okay, so we have a couple of different kinds of obstacles that we can put in the path. Ultimately, there are hundreds of different things you could put in there. But let's start with a couple that we've seen so far. All right, so let's say that we want to put a capacitor in the way. All right, so here is the symbol for a capacitor. It's two parallel plates, which should look reasonably reminiscent of the parallel plate capacitor. Another thing that we can put in the way would be a resistor. So we just put a zigzag line there, which I encourage you to actually practice drawing those. If you just try to draw any random zigzag, it usually doesn't look very good. It is worth practicing this a little bit. So in any case, the one on the left is a capacitor, and the one on the right is a resistor. And those are going to be a couple of the symbols we'll learn this quarter. There are not a whole lot of other ones that we're going to use. But as you go on, if you become, say, an electrical engineer, you'll learn many, many more. Okay, so since we can put obstacles in the path of the current, one of the things that we want to do is we want to be able to talk about the ways in which we can do that. All right, so one way is similar to what I just showed you. So for instance, we can take the path and we can put multiple objects just in the way, like this. Okay, so here we have two capacitors that are each going to affect the current in some way. And it turns out, just so you know, the current is still going to be the same at each point along this. It's a little less obvious with the capacitors, but it turns out that it's true that the current is not going to change when it goes through one of these capacitors. So the way that we describe components that are hooked up like this is we say that they are in series. So we could describe this as two capacitors in series. And the way that you can tell that they're in series is because there's only one path. Okay, so any of the current that goes out of the first capacitor goes into the second capacitor. There is no alternative option. The current can't go somewhere else. It all just goes straight through. Okay, so any current leaving one capacitor enters the other. Right? And that would be true no matter what the components were. So if they were capacitors, resistors, or something else, we still would be able to describe them as being in series. That's not the only way that we can hook up components, though. So another way that we can hook up components is we could take the wire. You take the wire and split it into two and have a capacitor on each branch like this. And then have the wires rejoin back together. Okay, so in this case, we have some current over here, and we'll have the same current over here. Okay, so it's still true that the current isn't getting used up, or additional current is not being generated anywhere in here. So at the beginning and at the end, that will be the same. But when the path splits here, what we find is that, in fact, the current will also split. So we'll have some smaller current here and some smaller current here. And before and after each of these, it will be the same. Okay, so these two have to be the same as each other. And these two have to be the same as each other. But those will be different than the currents that are before and after. And the one that I colored in purple and the one I colored in blue, those can be different from each other as well. Okay, so once the current goes through those two capacitors, it'll join back up like this. And so basically the current splits here and then comes back together. Okay, so the way that we describe this situation is we say that these are two capacitors in parallel. All right, and the way that we can tell is that there are now two paths. All right, so instead of having all the current from one go directly to the other, now whatever current goes through one is exactly the current that did not go through the other. Okay, so in this case, the current splits unequally and then rejoins. Right, so that's the way that you can tell that we have components that are in parallel with each other. Now, why do I say that it splits unequally? Well, it is not required that it's unequal. It would be possible for the current to split equally, but you have absolutely no way to know that ahead of time. So as far as you know, you could have almost all of the current go one way. You could have almost, a 50-50 split. You could have any other combination, but what you do know is that the current splits. You don't know how much. Okay, and so the reason that these two words are so useful, parallel and series, is because we can take a much more complicated network of components and split it up into parts that are parallel and in series. And so if we know what to do with a part that's in parallel or a part that's in series, then we can break down a complicated network into these simple parts. All right, so let's consider a more complicated network. Which, as I said, can be split up into parts that are parallel and series. Okay, so let me just show you an example of that. All right, so let's say that we have a wire like this, and then maybe two capacitors here, and then like this. Okay, so here is my more complicated network. And what I want you to notice is that parts of it are just in parallel or in series. All right, so for instance, I can identify that these two capacitors are just in series with each other. Whatever current enters the first resistor at the top, that same current will go through the other resistor and then out the bottom. Okay, so those two are just in series. Similarly, we have two that are in series over here. Now you might be a little confused by that because I didn't draw them in the same direction, but what's important is not the way I draw it. What's important is the connections. So again, any current that goes in the top is going to come out the bottom. So coming in the left on top, going out down the right-hand side. So those two are also in series. But once we identify that those pairs of capacitors are in series, those could be part of larger networks. So for example, I could take this capacitor that is in the middle branch there, and identify that that one is in parallel with that series network that I had a moment ago. Okay, so we could say here that the capacitor on the left side of this purple outlined region is in parallel with the other two which are in series. And then that network, that parallel network that I've outlined in purple, is in series with this other capacitor. Okay, so the idea here is we can just build up a complicated network from a bunch of parts that are each in series or parallel. Okay, so that one was in series. And here we can see that the green piece that I've outlined is now in parallel with the blue one. Okay, so maybe this one is in parallel with these. And then that very first capacitor up there is in series with the rest. Okay, so that may not seem all that helpful right now because we haven't talked about how to handle parts that are in parallel or in series, but the idea that I want you to see here is just that we can break up some really complicated network into simpler pieces that will interact in a way that you're about to learn how to handle. One thing I would suggest is to try to practice this. So try to identify in a complicated network parts that are just in series or just in parallel. And it's really important that you are not neglecting things that are also attached. Okay, so I might be able to say, for instance, that these two capacitors are in series, like this, but if there's anything else going on here, then I can no longer make that claim. I have no idea what's going on unless I know everything about what's going down that middle branch. It is absolutely not the case that these would be in series. They're only in series if that is it, if there's nothing else going on. Okay, so what I would suggest is you should practice drawing complicated networks. And then identifying series and parallel parts. Which is usually possible. So most networks can be broken down into a combination of series and parallel parts. And then I also think it's a good idea to try to come up with some that cannot. So try to come up with networks that cannot be broken down that way. It is possible to come up with some that are like that, but they're not as common, and there are additional tools that you can use to analyze those. So we're not going to study them in this class, but I think just as an exercise, it's useful to try to come up with situations that you can't handle as parallel and series so that you'll understand how you can handle all the others.